Hey guys, welcome to 12.4b, z-scores day 2. So we're going to be applying the information that we learned about z-scores in the last lesson, and then we're going to be evaluating z-scores using a table. So the first question here says, using the standard normal table, find the cumulative area that corresponds to a z-score of 1.15. So recall that 1.15, that's a positive number. So that means it is a standard deviation above our average of 1.15. So it's going to be to the right. We are going to evaluate using this table here. I'm going to explain how this works. So 1.15 is our z-score. Now that's a positive. There's two different tables. There is negative values and positive values. So since 1.15 is positive, we're going to go to this table. So on the left-hand side, notice it has 0.0 at the very top right here, and it goes all the way to 3.4. So we are trying to evaluate for 1.15, which means we need to find 1.1 on the left-hand side, since that's by tenths. So here's 1.1 right there, but it's not quite enough. So then if you look up here at the top, it's counting by hundredths, so we need to find 0.05 because that's going to be the one we want. So, and here it is right here. So what you need to do is match up 1.1. I'm going to use my cursor. 1.1 and 1.5 go all the way over here until I'm at this decimal right here at 0.8749. So that means that that is the percent or the amount of area under the curve for 1.15 as the z-score. So 8749, we're going to convert that to, so this was the decimal, 0.8749. We want that as a percent though. So we're going to say that is 87.49%. So that's the amount of area under the curve for 1.15. So everything to the left of 1.15. That's how that table reads, is the area to the left. Now, the notation that I'm going to use, just so you get comfortable with this, is area of, it's instead of like z equals, it's going to be a equals, and then it would be the 87.49%. So here's example 2. Using the standard normal table, find the cumulative area that corresponds to a z-score of negative 0.24. So again, I'm just going to go through how you find those values on the table. This time it's negative 0.24. So negative 0.2 is where we start, which is right here. And then 0.04 is right here. So we go to the point where those match up. So I'm going to use my cursor again just to show you. Start with the negative 2 and then right here. So that number is 0.4052. So that's going to be 40.52% if we convert that back to a percentage. Or 40.52%. All right, example 3. What percent of test takers obtain a verbal score of 470 or less given a mean of 500 and a standard deviation of 100? So this time we need to calculate the z-score. So you have to recall the z-score formula. This over here. Z equals x minus mu divided by sigma, where mu is the average and sigma is the standard deviation. So as long as we know the observed value of x, we can fill this out pretty easily. So a verbal score of 470 or less. So 470 or less means 470 or to the left of it, which is how our table reads. So 470 or less is going to be the exact value that we find from the table. So 470 minus, this is the average, this is our mu right here, and this is our standard deviation. So it's 470 minus 500 divided by 100. So that's going to end up being negative 30 divided by 100, which is negative 0.3. Now negative 0.3 only goes to one decimal place, which is fine, because on the z table, let me erase some of these little starred marks here so we don't get too confused. So negative 0.3 is, if there's no number after the 0.3, it's just going to be the first number after that. So it's 0.3821. I'm going to go back to the notes here. So our z-score of 470 ended up being negative 0.3. Now, if you see this, A of 470, that is talking about the value that you get after you've used the table, which I need to recall, 0.3821, which is that 0.3821, which we're going to write as 38.21%. So that's the area to the left of 470 because it's all the value less than. All right, I'm just going to do a couple more of these just so you kind of get the idea of how we use the z-score first, and then we go ahead and use the table. So I'm only going to do the first two for this example. So using normal distribution with a mean of 25, which is, so that's our mu, standard deviation is sigma. Find the value of the area under the normal curve. So the first thing we're going to do is find z of 30. So 30 minus r 25, I should probably write the formula off to the side here. X minus mu divided by sigma, it's our z. And then sigma in this case was 15. So if you type that into your calculator, I already have it typed out, it comes out to 0.33. Then we go to our z-score table. We're going to find positive 0.33. Get rid of some of this here. So here's 0.3, and then here's positive 0.03, so we are looking at 0.6293. So the area of 30 is 0.6293, which is 62.93%. Okay, now I'm going to do 45. So this one would be 45 minus 25 divided by 15, which comes out to 1.33, another positive number. And this is z of 45 because that's the observed value. So a of 45, if we go back to our table, we find 1.3. And then we find 0.3 again, so we just find that this is our number right here, 0.9082. Which is the same as 90.82%, because that's the area or the percentage taken up from that z-score. So you get the idea. I don't think I need to go through 10 and 22. There are a couple more confusing examples in example 5, so we're going to see this process again. So using the normal distribution with a mean of 100 and a standard deviation of 20, find the area under the normal curve. This time it gives us two different values between 65 and 80. We actually have to calculate the z-score for both 65 and 80 in order to do this one. So we're going to talk about that really quick. Because 65 is as low as we want to go. We don't want anything less than that. And our table reads all values less than specific numbers that we give. So let's calculate first for 65. So really quick, just think about the mean would be 100. Standard deviation is 20. So the first one is going to be z of 65 equals 65 minus 100 divided by 20. And that comes out to negative 1.75. Then I'm also going to calculate the other one just to save some time once I go to the table. So that's going to be 80 minus 100 divided by 20. And that comes out to negative 1. So we need to find the area for both of these. So negative 1.75 and negative 1. Let's go up to the negative table. Negative 1.75, so I'm here for negative 1.7. And then 5 is here, so I'm going to scroll down. Here's my number right there, 0.0401. And then I need to find a of 80, so I'm going to go back to the table. And we found that was negative 1. And since there wasn't a number after, we can just go to the first. So 0.1587. Now it's in between these two, so all we need to do is find the difference between these numbers, and that's actually going to be our answer. So we're just going to take a of 80. It's always the bigger one minus the smaller one for this. So a of 80 minus a of 65 comes out to be 0.1186, which is the same as 11.86%. So this one's a little bit more work involved because we have to find the z-score for both of those numbers and then subtract them to find the difference in the space in between. But it's the same process, just doing it twice. Now, when you have less than, this is going to be just the standard way of doing it, where you would do the z-score, 45 minus 100, 20, you would type that out, you would get negative 2.75, and then you would go to the chart, and I know what this one's going to be. It just ends up being 0.0030, which is the same as 0.3%. But since it's less than, it's already going to the left, so we don't have to do anything different for part B. So if it's less than, it's just like what we did up here with these problems. Greater than is different, so I want to do C. We're going to skip D because D is just like what we did for part A. When it's greater than, you still need to find the z-score, so we're going to do z of 115. So that's 115 minus 100 divided by 20, which comes out to be 0.75. So I'm going to go to the table here, go down to the positive table. This time I'm looking at 0.75. So here is 0.7, and then 0.05 is right there. So I find where those meet, which is 0.7734. Now I'm going to go back to the notes and write that down. So the area for 115 is 0.7734. But that's all of the values that are less than 115 because it's going to the left. Greater than would be looking at the values above 115. So what we actually have to do here is think about the whole thing would be 100% or just 1. So let's take 1 minus 0.7734. And that's going to give us all the space on the right side of it. And that comes out to be 0.2266 or 22.66%. So if it's greater than, you do need to think about the values on the right side of it. So you need to do just one extra step, which is subtracting that value from 1. Okay, just a few more to get through here. Example 6, a survey indicates that people keep their cell phones on average of 1.5 years before buying a new one. The standard deviation is 0.25 years. The cell phone user is selected at random. We want to find the probability that the user will keep their phone with the following times and assume all times are normally distributed for 2 years or more or less than 1 year. Maybe off to the side here, what you could do if you want is to draw the normal curve. We know that this middle section here would be the average, which is 1.5. 1, 2, 3, 1, 2, 3. You don't really have to do it for this one as long as you know the different values. So we could just do z of 2. So this is going to end up being 2 minus, here's our mu, and then this is our standard deviation. 2 minus 1.5 divided by 0.25. And this comes out to exactly 2, which is really nice. So we want to find a of 2. And so 2 or more years, keep that in mind. 2 or more years is going to be like greater than 2 or at 2. So let's find the value of 2 first. So it's positive 2, which is this one right here. So we go to 0.9772. So that's 0.9772. But again, this is going to be 2 or more years. So we got to do 1 minus 0.9772. So that's 0.0228, which is 2.28%. Not very likely that you're going to keep your phone that much longer. And then this one, less than 1 year, p of less than 1 year is going to be z of 1, which is 1 minus 1.5 divided by 0.25, and that's going to end up being negative 2. So we're negative 2 standard deviations on the left side. Let's go back to our z table, go up to the negative ones. Negative 2 is this one right here. So we are using 0.0228. Okay, and this one, that's just the exact answer. So shift your decimal over 2 places. 1, 2, so that's just 2.28%. This one is less than, so it's going to the left already. One last example and then we're done. A manufacturing process produces light bulbs with life expectancies that are normally distributed with a mean of 500 hours and a standard deviation of 100. So here's our mean, standard deviation. What percent of light bulbs can be expected to last between 500 and 670? So the first thing is here, since it's between, you got to find two different z-scores. So we're going to do z of 670, which is 670 minus 500 divided by 100. That comes out to 1.7. And we got to find z of 500. And that is 500 minus 500 divided by 100, which comes out to be 0. And then we need to find the areas for both of these. Now, the 0 one, you might just know right off the top of your head. And once you get to the z table, it'll make sense. 0, the first number, is 0.5, because that's 50%, because that's directly in the middle. So on either half of it, it's just 50%. So that one's kind of nice. So I'm going to write a of 500 is 0.5. You could put the zeros, but you don't need to. And then we got to find a of 1.7 here. So positive 1.7 is, here's 1.7. And it's just the first number, so that's 0.9554. So z of 670 0.9554. So this is the one where it's in between, so we're going to subtract those. So take the bigger number, minus 0.5, and it ends up being 0.4554, which as a percentage is 45.54%.